Real-world computer programming for kids of all ages. Step 38. Creating the table and gathering the data. Welcome back, kids of all ages. Let's jump right into, indirectly, creating the states table. If you closed it, start up DBWB, Database Workbench, and select the Tables folder in the upper left. That should populate the main pane of DBWB to the right. Give the table a name, specifically states, as rectangled below. And it shows a screenshot of where in DBWB you should add that name. Enter the first column's metadata. You may recall that metadata is data about data, so that it matches what you see below. Another screenshot showing the first column populated. As you can see, the name of the column is states ID. Its data type or column type is integer, and it's not null, PK, primary key, and auto inc checkboxes are all checked. In other words, this column cannot be null. It must have a value. It is the table's primary key, meaning this is the column that contains a unique value that no other row will have, identifying it, and its value will automatically increment by itself without us needing to do anything about it or even really think about it anymore. So how has the create table statement, the DDL, changed? Let's look at it. And then it shows a screenshot of the DDL tab, what's contained there. We see that the DDL is prepared to create a one-column table with the column we just, again indirectly, described. Its data type, name, and characteristics, not null, auto-increment, and primary key, have been recorded. So let's trust the DDL to be generated correctly and finish adding the columns and their characteristics on the Columns tab. For each subsequent column, we need to click the Add icon, rectangle below, and the screenshot shows where that is. Doing so in turn, enter columns and their values to match what you see below, and then there's a screenshot of all the columns that the table will contain. So how does the DDL look now? You might remember from the last step that I was expecting the create table DDL statement to end up like this, and then it shows that code. In actuality, it is now this, and it shows a screenshot of how it differs. So there are some differences, but do you notice anything odd, unique about one of the columns? What about the name column? It is italicized because it is the only column name that is enclosed in quotes. But why is that? Give up? It's because name is a reserved keyword used internally by the database itself, by the MySQL language. So it has to be treated specially so as to avoid it being a problem. It's like when you have two friends named Winston. It can get confusing unless you add their surname by either saying Winston Churchill or Winston Smith. Since there is MySQL's name and the states table's name, the latter has to be enclosed in quotes to set it apart as different from the former. Which name do you mean, the plain name or the quoted name? Noting that, though, I decide that it is safer to use a more specific name than the generic name, and so I go back to the Columns tab and change it from name to state name. Now the DDL is, and it shows a screenshot of what it changed to. Wallaby. The quotes are gone, and so naming the name column name no longer gives me the fantods. And it is pretty much the same thing as what I imagined it to be. The only real difference, besides name now being state name, being that what I thought would be constraint states underscore PK primary key states underscore ID is really just the last part of that, specifically primary key states ID. Now the time has arrived to actually run the DDL, which will create the table, hopefully. Let's see what happens when we click the create/alter table button here, and a screenshot shows you where that button is in BWB. I get this message, and it shows the message I get. That's okay. Let MySQL use whatever it wants to that way. I don't give a tinker's reservoir. Click the Continue button. Select Yes to the Confirm Create New Table dialog's prompt. And Wallaby. The table has been created, as can be seen below, and the screenshot shows that. The table now exists. But the table is, of course, empty. It contains no data. If we queried it, even if our SQL was perfectly formed, we would receive no data back, naturally. So now we will populate the states table with data, 50 rows of data, one for each U.S. state. We could painstakingly gather all the information, the square miles of each state, the 2020 population, the dates the states became part of the United States, etc., but the chances are that somebody has already gathered this information somewhere. One of the phrases you should remember is, Google is your friend. When it saves you time and effort and tedium, anyway, it's true. Google is your friend. So let's Google for that data so that we can save it to files and subsequently populate our states table with it. Googling square mileage for each state, I get this. And it shows the link URL that comes up, which is just what the chiropractor ordered. It's even in rank order. I copied it all, pasted it into a text file. The first 10 records are, and it shows those, from Alaska number 1 in size to Oregon number 10. So to use this data, I'll format it for a CSV file. I can then loop through it programmatically, calling inserts to the database on each row or line. I will have to combine all the various bits of data first, though, not just square mileage, but also 2020 population, date admitted to the union, etc. So I remove all the commas by replacing them with nothing, and save this file as squaremileage.txt and commence to let my fingers do the Googling again. This time I Google 2020 population for each state and found this, another URL. So I did the same thing with the data I found there. The less than optimal thing about this data is it contains a lot of junk. Junk meaning stuff I don't want. The population from 2018, the percent increase or decrease, and things like that. I only want the first 3 columns. Rank, name, and rank, name, and 2020 population. It's easy but tedious to strip the extraneous data from the end, but out to the right. But the whole purpose of computer programming, pretty much, is to kill tedious work dead. Let the machine do it. So we will write a quick utility to strip off all of the junk later before combining the various data points in a CSV file to get ready for populating our state's database table with. Next up, we need the dates admitted to the union for each state. By Googling date admitted to the union, I got this, another URL with that information. The data I gleaned from there was in this format, and it shows each state in order from the earliest, Delaware, on down to number 10 is Virginia, and then it goes on down. 49 and 50 are actually Alaska and Hawaii, and early 1959 and then the middle of 1959. The dates are going to be slightly problematic because they're in human-friendly format, which is not computer-friendly format. So it also had asterisks or stars on some of the dates, after some of the dates. I deleted those as I have no use for them. I will have to convert the dates from the human-friendly way that they appear in the list above, such as December 7, 1787, to the format the database needs. The database expects when it sees a date. I saved this data to a text file also. So we have what we need that way. We've got the data we need. The rest of the columns or fields are either going to be a surprise, and I'll grab those pieces of data myself, unfortunately, painstakingly, or data that the user can add themselves, namely the have resided there, have visited, and notes columns. In the next step, we will write a utility, a quick and dirty app that only does one thing and sometimes only one time, and then it has had its day to populate the data into our database. After that, we will query the database to show whatever it is that interests us about the data. Until then,